In this session, I'm going to talk about what is cloud native. So let's define what does it mean to be cloud native. If you look around today, there are several hundreds of apps and services from food delivery to cash transfer. All these apps are comprised of several hundreds of services in production and which are deployed several times a day. For example, Netflix, Uber, Amazon e-commerce website have hundreds of these services. So this is where cloud native comes in. Cloud native is about speed and agility. It's about getting ideas to market immediately. The difference between a native solution and a cloud native solution is a cloud native solution allows you to deploy, iterate, and redeploy quickly and easily. You can fix bugs easily, and you can deploy a solution whenever it's needed as long as it's necessary. That flexibility is what makes it easy to experiment and implement in the cloud. So cloud native is an approach to building and running applications that exploits the advantages of cloud computing delivery model. Cloud native solutions are also able to elastically scale up or down on the fly without disruption to deliver the appropriate cost performance mix and keep up with the growing or changing demands. That means you have to only pay for and what you use, just like electricity. Just pay for what you use. In this session, I'm going to talk about one of the DevOps concepts, the notion of pets versus cattle for the service model. This is first introduced by Bill Baker on the topic of scaling up versus scaling out. And so in the pets service model, each pet is given as a loving name like Apollo or Saturn or Neptune. And these are uniquely and lovingly hand raised and cared for. And when they get sick, you nurse them back to health. And you scale these up by making them bigger, by adding more RAM, by adding more memory, by adding more hard disk space. And when they are unavailable, everybody notices. So the examples of pet servers are mainframes, solitary servers, load balancers, firewalls, database systems, and so on. In the cattle service model, the server is actually instantiated by using a template. And that's why their identification numbers are web01, web02, and so on. Just like cattle. And just like cattle, the numbers are tagged to the rear. So each server is exactly identical. And when one gets sick, nobody notices because you can replace that with another one. You scale up by adding more of them, and whenever one is unavailable, nobody notices. Examples of cattle servers are web server arrays, NoSQL clusters, queuing cluster, search cluster, database stores like Cassandra, big data cluster solutions, and so on. The evolution of cattle model evolved from Iron Age, where you had bare metal racked servers, to the cloud age. In cloud age, everything is virtual. Right now, you don't even know whether this is a virtual or a real. It is so close. And they're all programmable through a web interface or command line interface. Who are the candidates for cloud native? What kind of applications might be a candidate for cloud native? So the examples are a strategic enterprise system that need to constantly evolve business capabilities or features, an application that requires high velocity release with high confidence, a system where individual features must release without a full redeployment of the entire system, an application developed by teams with expertise in different technology stacks like Uber, an application with components that must scale independently, which is microservices. All these kind of systems are a right candidate for cloud native apps. Under the Azure cloud native apps, we have three different kind of services. One is the Azure App Service, Azure Functions, and Azure Logic Apps. So I'm going to talk about Azure App Service. So what exactly is Azure App Service? So let me give you a little bit history about Azure App Service. In 2012, Microsoft added Azure websites to its Azure Services portfolio, and this was created for the users to run web applications in Azure. This service became very popular, but it had missed out some features for APIs. So then developers were requested more specific features. So then Microsoft added two different services. One is for API apps, and another is for logic apps. And that is how you will see that we have now Azure Logic Apps, Azure Functions, and Azure App Service. But Azure App Service itself comprises of several services like web apps for running web and API applications, function apps, that is Azure Functions, to run a small piece of code when an event happens. For example, like when you drop a message in a queue. In this session, I'm going to show you how to create a new web app using Azure App Service. So first, let us see where I am. Let me go to my source directory. source/repos/ I'm going to create a new directory here. Let's call it sept 2020. I'm going to cd to September 2020, and I want to create a new web app. So I'm going to say .NET. I'm going to use Azure Client and .NET commands here. New web. So it's going to create a template for ASP.NET.Core. So I have a template ready. Now I want to run this locally. So I'm going to say .NET run. I'm going to see what happens. So when I do this, it shows me the endpoint where the service is active. So I'm going to click on this, and it says hello world. So let's see how the source code looks like. So I'm going to open the folder. So if you can see my screen here, I'm going to make it a little bigger. You can see, yeah. So it has just two files, startup.cs and then program.cs. So program.cs actually invokes startup.cs. As you can see here, web builder use startup. So let's go to startup.cs and see what happens. So I'm here in startup.cs, and as you can see here, the hello world actually has come from this endpoint. So what this means is it is asking the system to add an endpoint for slash. Slash is the root of the web application, and it is mapping a GET protocol, HTTP GET protocol, so that whenever you type slash, it takes you to that location. So for example, here in this case, I'm typing slash on the browser here, and it took me to hello world. So let's change this and see what happens. I'm going to change this to I'm at the root level. I'm tired of hello world. So I'm going to save this. I'm going to run it again. So let's run it again. So once I've edited the file, I'm going to run .NET run again. I'm going to say .NET run, and it's going to give me an endpoint where the service is running, which is here. I'm going to click on this, and I can see that it is changed to hi, I'm at the root level. It has changed from the hello world which we did earlier. Now I'm going to deploy this into Azure, and I'm going to show you how to create a Azure App Service. So let's go here to this Visual Studio Code, and I've installed an Azure template for the app service. So this is the app service. If you can see here, there's app service written here. I'm going to click on plus here, and I'm going to give a name. Let's call this hello root service, just because everything else is taken. I'm going to press enter. I'm going to use Linux, and I'm going to use .NET Core 3.1, and it's going to go ahead and create a service plan and also an app service for us. And once it finishes creating it, we're gonna deploy the web service which I've just written. It has completed finishing creating the new web app. As you can see here, it has given us an endpoint. So let's click on this endpoint and see what happens. So as you can see here, when I click on my hello root service endpoint here, I'm able to see this default Microsoft Azure web page that shows that gives a message to go to deployment center or quick start. So here we have already coded the app, so I'm going to just deploy it directly. I'm going to click on deploy here, and this will change the web. Whatever you're seeing now will actually change to the code that we have written in the web service. So let's click on deploy. It's deploying to the hello root service, as you can see here, and is asking me whether it to always deploy this. I can say yes. It's deploying to the hello root service. Check the output window. So I'm going to click on the output window. Once the deploy is done, you will see that the HTML page has changed from the default .NET Core to what we have typed, which is hi, I'm the root service. And also you can see on the left side, I have the hello root service. There is a wait icon that is running, and it is part of the app services that I've created. So as you can see here, the hello root service is working. So once this is completed, you will see that it says now it is completed. Now I can browse the website. So if I browse the website, I would see the message that I've coded, which is hi, which I'm going to show you here, which actually is right here. I'm going to see this. So let's see whether I can see this. I'm going to go back to my browser here. So I have this message here. So since I've deployed it again, this will override this current deployment, and it will show you the hi, I'm at the root level message. So when I'm reloading it, it has changed the message. So that means the deployment has gone through correctly, and now I have my own message here. So this completes the Azure App Service deployment tutorial. In this session, I'm going to talk about the various settings that you can have for an app service. So as you can see here on my screen here, I can choose which development stack to use out of ASP.NET, Java, Node.js, PHP and Python, and I can choose whatever the stack I like for my app service. So app service is pretty flexible for what stack you can use. Let's talk about some of the shared features here. Let's talk about deployment slots here. Now, a deployment slot is one of the features that adds a lot of value. So a deployment slot is a fully functioning app service, like a web app, that runs parallel to your original web app. So here I have IOScan API and IOScan API staging. So both these are running in parallel, and I can specify some amount of traffic that to come here. For example, I can specify 5% of the traffic to arrive at my staging to do a testing. For example, so when you have one or more deployment slots, you can use them to test in production. You can configure how much traffic you want to be routed to each deployment slots. For instance, I could route 10% to the staging and the rest to production by just changing the value here, as you can see on the screen. So 10% of my users will be sent to the deployment slots, and those users get to test my new features. Suppose I have some new features in staging, I can route those 10% of users to this staging endpoint. There is a lot of advantage to using deployment slots. You can use a deployment slot to deploy a new version of your application and test it. And the beauty of this feature is you can swap a deployment slot to production with zero downtime. We'll talk more about this as the video progresses. Let's talk about deployment center. Okay, you can use deployment center feature to connect your source code to a repository. For example, here in this case, I have connected my deployment center to my repository in Bitbucket, as you can see here. Now, the advantage of this is continuous deployment. Whenever I change the master branch, as you can see here, whenever I update my master branch, this deployment center will pull the latest source code and then do an automatic deploy. Now, I'm in the settings section here. These are shared settings that you can use within all your app service types. Now, and some of them may not be available for your function apps in the serverless, but most of them are pretty much available. So first is application settings. The application settings let you configure everything from the .NET framework that the app service runs to the HTTP version it runs. Everything can be configured here. Next is authentication and authorization. App service allows you to easily require users to authenticate before they can use their application. You can just flip on this switch and then you can select whatever is required, like Microsoft, Google, Twitter, and so on. The next is application insights. I'm going to click OK here. So application insights is an extension that runs in the app service. Now this extension collects performance and diagnostic information from the app service and sends to the application insights instance to monitor and analyze your app. So you need to have an application insights instance to get this to work. The next is identity. The identity service allows you to assign a managed service identity to the app service. Now this is an identity that lives in the Azure Active Directory and can be used to authenticate other services like Azure Key Vault. Using this, you don't have to store any credentials in your code or configuration files of your app service. That is the advantage here. The next one is backups. You can create backups of everything in your app service on a regular basis. Backup saves the content so that whenever the application goes down, you can get it back, or if you have made a mistake, you can always revert it to a previous version. Custom domains. When you create an app service, it has a URL, but that URL has an endpoint like Azure websites.net. As you can see here, it has an endpoint here, but you want to customize it to your custom domain. In that case, you can buy a domain and couple it with your app service straight from the Azure portal itself. So the domain you buy is here. For example, I bought this domain here and I have mapped my IOTAScan API.Azure websites to the API.IOTAScan.com. Next is network. Next is SSL. Now here I have set my minimum TLS version to 1.0. I can set it to 1.1 and I can also set HTTPS to on. See, it has upgraded my TLS version here, as you can see here. And then my host name is actually mapped to my privacy certificate which I've just uploaded. Networking. You can protect your app service by adding IP restrictions. You can also create hybrid connections to your app service that connect to services and data store that runs somewhere else in Azure. For instance, your own data center. That's what you can do using this. You can also use virtual networks to connect securely to your app service. Now, in this section, I'm going to show you how to scale up your service. There are many cases when you want to scale up your services. There are two things here, scaling up and scaling out. When you say scale up, you're always increasing your memory, you're doubling up your memory, you're doubling up your CPU, you're doubling up your AC. For example, if you look at here, I have this Azure compute units. I'm actually doubling it up here in the P1 V2 and also tripling up here in the P2 V2. So and so on and so forth. Now, based on the budget you have and the need that is there, you can choose the recommended pricing tiers from here. Now, scaling out. Scaling happens when you increase the number of instances you run. In the app service, you can scale out with a manual slider to increase the amount of app services you want to run, or you can do an auto scale. As you can see here, I have my auto scale selected here. It says my auto scale instance to count to 3 when there are more service requirements. I can also specify the minimum instances to run and the maximum instances when I scale out. Web jobs. Web jobs is a very interesting feature of app service. Web jobs is actually a type of service that you can run background jobs, and they can be triggered by a schedule or by an external event, like when a message is arriving on a queue. So all you have to do is write the code that does something when a web job runs. This is very powerful. Web jobs are very similar to Azure Functions, which run function apps. In fact, Azure functions are built on the same technology as web jobs. Functions are the evolution of web jobs. But in this case, a web job is running on an app service. You can use the Azure Notification Hub to send push notifications to your apps. I have already configured here a namespace and a hub name. Please refer to my other video on YouTube for my how to use notification hubs. So basically, if you want to send a push notification to applications, you use this push feature in the app service. Okay, next is MySQL. Now this feature is not extremely useful, but if you want to easily use MySQL database with app service, this basically instantiates a MySQL database in memory with the app service, and you can use it instantly. But the problem is, once you scale out, this will not work because this is per instance. When another instance of application runs, it uses a new instance of MySQL data, and the data will not be available on the new machine. Change app service plan. So in this section here, you can change the app service plan that your app service runs on. This can help when you want to co-locate your app service apps in one app service plan to save costs, or to spread out app service over multiple app service plans to increase performance. Clone app. If you quickly want to create a app service app that is exactly same as IOTA scan API that is right here, this allows you to create a copy of your app service app and saves you a lot of time. But remember that clone app does not clone custom domains or copy any content of the application. So it's just a shallow copy of your code and data if the data is available in a separate web server. You can use the console option to manage your app service through a console by using command lines like mkdir, or I can use the directory. I just want to see what is there, so I would just use dir command here. Dir. So I would know what files I have here using my dir command. So you can use all this using your console in the under the development tools, advanced tools. Now the advanced tools feature takes you to the Kudu environment. This is a management web application that runs next to your app service app. In the Kudu environment, you can manage the file system, manage app service extensions, see the processes that are running, and more. Most of the features that made the Kudu environment is unique in the past are now elevated to the first class app service like the console feature. See you guys in the next session.